Hello and welcome to the iBless introductory video. In this video, the project composition, design and diagrams are going to be explained. The project name is iBless, the team member is Luis Miguel Carrillo, the role is Scrum Master as team member, the mentor Jaime Borras. Problem definition. There is a lot of missing calls and text messages in communications. Right now, there is no system to manage users. There is no way of visualizing data such as time talked, vibration used, where the message was lost, information as such. And there is no way to connect to the current app that my clients have. This is the Gantt chart for the project. In the Gantt chart, one can see that the documents were finished at the beginning, then the subsystems were developed, and finally testing was conducted throughout the semester. Let me continue by talking about the user stories. There is a lot of user stories that were developed for this system, but I'm going to focus on two in particular: create user and analytics. Create user is where the heart of the application is. Any company that has bought the product is able to create another user such that they can provision the ability to record SPI values for them. So you create a user called userN. This userN logs in the iDroid application and then records information about the environment where he is and the DBA values he is collecting. Analytics uses the previous information. All information that is captured by the device is going to be able to be visible in the forms of graphs and charts. As I said, there were a lot of user stories, and this is a use case diagram picturing each of those. In total, there are 7 actors in the system, although safety management is more like a passive actor, meaning that it doesn't initiate any use case. Let me talk about the use case for create user. In this use case, the participating actors are the master user or subscriber. The master user accesses the create user function of the website. Then iBless responds by presenting a form to the user. The master user fills all the information and clicks submit. iBless receives the information, validates it, and creates a user account under the master user table. A user account has been created, and now the user is able to log in the system, as well as in the iDroid application. Then the master user is able to see the newly created user. View analytics. In View analytics, the universal user accesses analytics. Then iBless responds by presenting a form to the user. The universal user provides the username and password, and iBless responds by validating the information. After validation, the universal user clicks in the analytics label, and they are going to be presented with a form in which they can query information. This is general information about the system. Then the universal user can click on a company label and see all information regarding that company, as well as query information in order to narrow down the criteria in the results. This is a sequence diagram for create user. All the steps I talk about are pictured here. This is a sequence diagram for analytics. Here are the queries, and you're getting information, and here is the company that has been selected. System decomposition. The system is a 3-tier system, separating view, logic, and data, which decreases coupling. The system requires a PC with Windows 7 or any other operating system in order to access the website. Now, in order to host the website, we are using a Windows Server 2012. The software is listed there. system data design, we are using a database, MySQL database, hosted using Amazon RDS, which is a web service that is provided with Amazon Web Services. This is the database diagram. Security and privacy. Security comes in different fashions in this system. First of all, there are different account levels, so that users of the most basic account level cannot access information critical to the system. Only managers or the universal user could do so. Then we have encryption, in order to make sure that even if for some reason Amazon is hacked and the information is compromised, the information of our clients won't be, because sensible information such as the password will be stored using a SHA-1 encryption, which makes it impossible to retrieve the original value. It's a hashing algorithm, and we are also adding a salt in order to make it more unique, using a GUID. As well as we are using parameterized queries in order to protect ourselves from SQL injection. Here's the minimal class diagram for create user, and here's the minimal class diagram for analytics. Then we have the state machine diagram for create user. The user is created, here's the instance of the user, then if it's valid, the user has been added and the state has changed, and we go to the final state. If the user was not valid, there was some error, such as duplication, the error has to be fixed. Then we have the analytics state machine diagram. There is the default state, which is default information. After a query, the state has changed, and there is filtered state, and then after a new query, the state has changed again until the user exits. Here is the algorithm for create user. The user clicks the add user and inputs all this information. Afterwards, the user clicks submit. If there is an error, the user is going to be notified and is going to recover and repeat the same steps. If there is no error, the user has been created. Analytics. In analytics, the logic goes like this. The user accesses analytics, clicks on analytics, then queries the information. If he wants to continue querying, he can do so. If he wants to go to a particular company, he can also do so. And here the information is displayed. If he doesn't want to do anything more with information, he can simply exit. Otherwise, he can query further the information. Test cases. We used one sunny day per scenario and one rainy day per scenario. In create user sunny day, we validated that the system was behaving as expected when correct information was provided. In this case, we are creating a new user that doesn't exist in the system, and we are giving unique information such as the phone number, the username, and the email address, which must be unique. The user was created, the test passed. Then we have the rainy day, which is the same, exactly the same, because in this case the test should fail. The creation should fail, since the user already exists on the system, and the username is not unique, the email address is not unique, neither is the phone number. And in this case, the user was notified of the duplication, and the test passed. Finally, we have the sunny day for analytics, in which we enter to the company 1327 and query it from an SPL value from 0 to 150. The information was displayed, given the query, and the test passed. Then we try querying from a string value to another string value, which is not possible, so no constraint was applied, and the expected output was the same as the actual output. Now let me give you a demo of what I am talking about. for example, I know that a user with this email address already exists. So the system is going to tell the user that this is wrong. There was a problem with email address. If I change the email address and the phone number, I'm going to create a new user. In the case of analytics, I can query from 0 to 150 and the information is reduced, but I cannot query from Word to Word 2. Nothing happened. Well, thank you a lot for watching this presentation, and I hope that this system goes big. Thank you a lot.